the scanning process in greater detail. A fluorescent lamp exposes the original. Through a system of mirrors and a lens, or through the use of fiber optics, the reflected light from the original is sent to the CCD. The CCD is a row of very sensitive photocells. The photocells divide an original image into tiny units called picture elements, or pixels. Each photocell captures the intensity of light reflected from one pixel. The CCD scans the original line by line. The horizontal scan is called the main scan. The CCD unit scans all the pixels in a main scan line simultaneously. The vertical scan, or sub-scan, is produced by adding one main scan after another until the entire image has been scanned. The detail of a copy, known as resolution, is determined by the number of dots per inch, DPI, and the number of lines per inch, LPI. In scanning, DPI is the number of pixels in a main scan. The greater the DPI, the better the scan resolution. A DPI of 400 means there are 400 pixels per inch across the main scan. LPI refers to the resolution of the subscan. An LPI of 400 means there will be 400 main scans for every vertical inch. Each photocell in the CCD generates an electrical charge in the millivolt range and stores it in a capacitor. A control process is used to move the charges out of the CCD sequentially. The analog data is passed serially to the CCD preamp board, where the charges are inverted and amplified. The amplified output should range from 0 volts, representing a pixel that is pure black and reflects no light, to some predetermined maximum voltage for a pixel that is pure white. The voltage for each pixel in a main scan is sent to the analog to digital converter. The A to D converter assigns a numerical value to each charge by using binary digits, which are referred to as bits. Each bit can be off or on, represented by a 0 or a 1. For instance, if an A to D converter were to use a 1-bit system, it would be able to assign either a 1 or a 0 to a charge. A 1 would be assigned if the photocell for that pixel received less than a predetermined minimum amount of light. A 0 would be assigned if the photocell received more than the predetermined minimum amount of light. Such a system would copy pixels as either black or white. Shades of gray, however, could not be reproduced in this imaginary 1-bit system. Gray pixels on an original would be seen as either black or white. If the intensity of light reflected from a gray pixel generated a charge less than the minimum level, it would be assigned a 1 and appear black on the copy. If the intensity of light reflected from a gray pixel generated a charge greater than the minimum level, it would be assigned a 0 and appear white on the copy. Obviously, a 1-bit system is inadequate when it comes to copying original images with pixels that are somewhere between black and white. To allow for the many different voltages that an original with varying shades may have, digital copiers use 6 or 8-bit processing. 6 bits, any or all of which can be on or off, offer 64 different possible combinations, and therefore can represent 64 different voltages. In an 8-bit system, there are 256 different combinations, so black, white, and 254 gradations or shades in between can be represented. Pixels that are black generate no charge, and in our example here, are converted into 8 ones, a binary representation of pure black. Pixels that are white generate a predetermined maximum voltage after amplification, and again, as in our example here, are converted into 8 zeros, a digital value of 0 that represents pure white. A pixel that is a medium gray might generate a charge of approximately 1.5 volts after amplification. Its 8-bit or binary combination would look like this. representing a numerical value of 129 on a scale of 0 to 255. Our examples here are based on copiers that digitize an analog signal by assigning a 1 for black and a 0 for white. This process may be inverted in some machines. Either method will allow a digital copier to convert analog signals from each pixel into a binary number that can be manipulated, stored, or even transmitted before being converted into a laser light impulse and directed onto the photosensitive drum. Now let's look at a simplified example of the digital copying process. In most digital copiers, two functions must be performed before an original image is scanned: auto gain and auto shading. Auto gain increases the amplification of video data signals reflected to the CCD by a white reference plate. When the signal from any one photocell reaches a predetermined level for white, the amplification factor is maintained and auto gain is complete. Auto shading can now be performed. Auto shading compensates for variations in the output of each individual photocell. Such variations are due to the different sensitivities of each individual photocell and the fact that the fluorescent lamp is brighter at its center than it is at its ends. There are two auto shading methods: white shading and black level correction. White shading is done with the lamp on. Pure white light reflected from the white reference plate should generate a predetermined maximum charge in every photocell. White shading adds a value to bring the output of any photocell generating less than the predetermined maximum up to the right level. This value is stored in RAM and added to the output of the photocell during every main scan. Black level correction is done with the lamp off. Since no light is being reflected to the CCD, all photocells should generate 0 volts. Black level correction stores in RAM the voltage level of any photocell that generates a charge. That value will be subtracted from the output of the photocell during each main scan. White shading and black level correction eliminate distortions by ensuring that the signals received from every photocell in the CCD contain only image data. Now the image can be scanned. Each main scan is digitally transmitted to the image processing unit pixel by pixel. The image processing unit uses the digital or numerical information regarding each pixel for further correction functions or to change the data to provide different copying features. Smoothing softens the edges of halftone areas on the original, such as photographs. Modulation transfer function correction, or simply MTF, ensures that small areas on an original, for instance the period at the end of a sentence, will not be overlooked in the digital process. A period might spread across a number of pixels, but fail to meet a minimum threshold amount in some of them. MTF is able to correct for this by establishing new minimum thresholds for the pixels in that area. Image processing also allows for main scan magnification or reduction. Complex calculations are used to reposition pixels on the copy while altering neighboring pixels so as to match the density of the original. Dithering is a process that converts gray areas on an original into black and white patterns on a copy that appear gray to the eye. Some digital copiers are capable of reproducing a limited range of grays by changing the laser power for each pixel on a copy. Dithering, however, greatly increases the number of grays a copier can reproduce by using a selection of pre-programmed patterns or dither matrices to approximate an extremely wide variety of grays. The image processing unit also allows digital copiers to offer advanced copying features such as slant, negative-positive, outline, mirror image, shadow, and others. Once the original image has been processed, exposure of the drum by the laser beam can take place.